loss of lives, damage to crops, infrastructure. It is high time that we revisit how we manage our resources, land and water, excuse me, land and water in order to minimize, if not avoid, the adverse impacts of natural calamities. This presentation is a component of a research on landform dynamics and its implication to geohazards and resource management. Okay, so we have here a watershed. A watershed, a catchment, or a river basin is a landform unit for planning and managing resources. These landforms are formed from a complex interaction between tectonics, erosion, and climatic forces over a geologic time setting. And take note that we all live in a watershed. What happens upstream will have repercussions downstream. Okay, so watershed or river basins. These are hydrologically defined landforms comprising of drainage divides and stream channel networks. Previously, these landforms are assumed to be static. However, observation of stream capture, long-term erosion studies, and numerical modeling demonstrated that watershed shape and network topology adjust in response to any perturbations to boundary conditions. Now we have also geomorphic analysis, which will give us an idea of the dynamic nature of these landforms and which further will provide us guidance on watershed management process. So in this study, we integrate chimetric and the commonly used hypsometric analysis as rapid assessment tools in watershed characterization and prioritization as applied in the island of Bohol, central Philippines. So to introduce further, the chimetric is a measure of drainage divide stability, fundamentally based on the differential rates of river channel erosion on opposite sides of a divide. Chi is the integral solution to the stream power model, and it is expressed using this equation. To recall, we have this stream power model. This model relates incision rates along channel, a riverbed channel with discharge, erosion, and erodibility properties. Chi maps, with chi analysis, we will produce chi maps, which will provide a rapid visual assessment of divide stability over large area and also characterize the variability of river networks topology and geometry in a watershed as they transmit tectonic and climatic signals throughout the landscape. So in here, we have a figure here which shows a disequilibrium state, a divide in this equilibrium state and a steady state divide. So with chi analysis, this equilibrium state divide is where when the chi values at the channel heads differ, but at steady state, the chi values at the channel heads of the two opposing streams are more or less the same. Now, when the divide is in this equilibrium state, there is a tendency for that divide to move or to migrate. Now, for hypsometric analysis, hypsometry quantifies the erosion proneness and stage of geologic development of a watershed. Hypsometric analysis studies the distribution of ground surface area or horizontal cross-sectional area of a landmass with respect to elevation. The hypsometric curve and the hypsometric integral of a drainage basin are common tectonic geomorphologic indices. And with the geometry of the hypsometric curve, would classify a watershed into different stages of geologic development, while HI represents the area under this curve and expresses the volume of a basin that has not been eroded. So to do this study, we have two major analyses here, the divide stability analysis with chi, and the other is the hypsometric analysis. The divide stability analysis with chi, we use the divide tools, which is a set of MATLAB-based tools built on top of Topo Toolbox. We use a 30-meter SRTM DEM, a flow direction grid, and the parameter values for minimum accumulation area and theta. The divide stability criterion that we use here, as described by Forte, is is the standard deviation. So for a steady divide, the mean of one side of the divide should be within one standard deviation of the mean of the other side. Otherwise, that divide is unstable. Then we selected all those unstable divides and we proposed this another metric, which is the degree of potential divide mobility. And this chi-MD is the absolute value or absolute difference between the means of the two opposing, the chi-means of the difference between the chi-means of the two opposing stream channels. Now, chi-MD are classified into low, moderate, and high with values of less than 135, 135 to 255, and more than 255 respectively. These values are based on the values that we get from the unstable divides that we identify in the study area. With hypsometric analysis, we started this one with the delineation and parameterization of watershed and subwatersheds using a DEM. Again, it was a 30-meter is RTM DEM using the SWOT model. The basin and sub-basin attributes are used to compute the hypsometric curve and HI. The hypsometric curve is a plot of the relative area versus the relative altitude. Then the value of the relative area is 1 at the lowest point in the basin where the relative elevation is equal to 0, and it is 0, or the value of the relative area is 0 at the highest point of the basin where the relative elevation is equal to 1. Then we compute the hypsometric integral using this equation. So here the results and discussion. This is an example of a chi-map. So this is a chi-map and the major basins in the island. A here highlights the major basins. B shows here the chi-map of the stable divides and also the histogram here. And C, this is the chi-map of an unstable divide and also its histogram. We can see here that the histogram of an unstable divide, there is a big gap here. This is the two opposing streams, values of the two opposing streams. While here in stable divide, the chi values are overlapping. So first we have this chi-MD and the divide migration. So this figure here shows the stability analysis as applied in Bohol Island. And A here shows the drainage divide sections colored according to the values of chi-MD, while in here B shows the direction of the potential migration and their chi-MD classification. So highly mobile divides are located in the upper headwaters of the watershed. This one here, the red line here, that borders smaller watersheds draining towards the southern coast of the island. And the highly mobile divides, as shown in this rose diagram, are moving in a northwest direction. So there are, I think, six divide sections that are identified or classified as highly mobile, and 4 of these are moving towards, has the potential to move towards the northwest direction. So with this potential movement, this entails changes in watershed areas and also maybe reorganization of the river networks. Second, we have the result of the hypsometric analysis at different scales. So this figure here shows the spatial variation of the hypsometric integral. In A, this is for the whole island, which has an HI value which ranges from 0.1 to 0.6. And then in B, this is we selected this major drainage basin within the island because this is an agricultural basin or watershed, and it has an HI value of 0.9. While we also selected 3 subwatersheds at the lower portion, middle, and upper portion of this major watershed, and we found different HI values. 3 here in this figure C here, we have the hypsometric curves of the watershed and also the subwatersheds. Hypsometric curves of this big watershed and also of the smaller subwatersheds. And the broken lines here represent the reference hypsometric curves that was adopted from the study of Pavano. So from this analysis, we found out that geologic development in the island varies spatially. We with the disaggregation of watershed, of a bigger watershed into smaller sub-watershed, you found out that there are areas of highly erosional nature. Now, this information can facilitate the identification of small and manageable areas as target for conservation. Then we integrate the two indices. So we have here the landform dynamics for the landform dynamics prioritization. So this map shows here the subwatersheds that share with high chi-MD divide sections shown in the second figure where we have this red line here. These are the areas, or these are the divide sections which are classified as highly mobile. Now this subsection, this divide here is shared with 24 sub-watersheds. Okay, so the color indicates HI values, light to dark, which means low to high HI. The dark colored sub-watersheds have HI of 0.5 and up. In one of these sub-watersheds, the 2005 Mayana landslide had occurred, and we have here the latest satellite image of the landslide area is extracted from the Google Earth. Below this here, are the hypsometric curves of the 9 sub-watersheds arranged from low to high values. So the intersection of the highly mobile divides and the highly erosional areas trim down our target areas. Prioritization can be done further based on the HI values from highest. In this case, we have the sub-watershed 431, this one here, and to the lowest sub-watershed 477 here. So we can still do a prioritization based on the HI values. Then these areas, the dark colored here, these are the areas that are highly recommended for conservation or allocating their uses to forest use. If not, appropriate best management practices and standards must be observed and enhanced. So to conclude, the study integrates the topographic metric chi with hypsometric analysis and introduces chi-MD as a new index in watershed characterization. The introduction of chi and chi-MD is a new development in watershed characterization process, wherein the stability of drainage divides and the degree of drainage divide mobility coupled with the stages of geologic development are considered in identifying and prioritizing areas for conservation. So the intersection of highly unstable divides and the highly erosional areas help us narrow down our target areas, which facilitate area prioritization process. The method that is presented in this study could be used as a rapid assessment tool in the characterization phase of developing a watershed management plan and program, and this method can also be applied in other watersheds. So these are all. Thank you for listening.
Thank you very much, Emelida. The floor is now open for questions. From Mom Sheila, um, watershed is considered a resource if a resource is very important, which at present has been subjected and impacted by various external factors, both natural and man-made. Our LGUs are wanting in terms of how, to manage them. How will LGUs utilize your study in relation to their watershed management efforts, such as in prioritization of conservation?
Okay, so this information is very important to the LGUs. They can use this one in developing their CLUP, um, CLUP, comprehensive land use plan. They can integrate the result in their land use plan, and they can also, develop policies where to put up development structures, where not to put up development structures, and most important, I think, is on allocating land uses. So they can now identify where in their area they can recommend for a specific land use based on the data that or information that is provided in this study.
Okay. Um, we have questions. One more, two from the audience. Okay, I think there's none. Again, thank you very much, Emilita. It's a very, very insightful presentation. And I do hope that this, is something that will be considered by our LGUs when it comes to, planning.
Yeah,
Thank
yes,
you
sir.
very much.
Thank you, sir, too.
Okay, let's proceed to our next presenter. Our next presenter is Sheila Griengo from Central Luzon State University. Her presentation will focus on automated furrow irrigation system for maize, Z maize Elvar Sakarata, production. Sheila,
Good afternoon, sir.
good afternoon.
Yes, I'll first share my screen. Is my screen visible, sir?
Yes, we can see it now. Thank you.
So I'll start. So to our session chair, panelists, co-presenters, ERDT scholars, and attendees, good afternoon. So my paper is about automated furrow irrigation system for maize production. So I am Sheila G. Griengo, a CLSU graduate student, together with my co-authors, Dr. Armando N. Espino Jr., Dr. Marvin M. Senense, Dr. Romeo B. Gavino, Dr. Vitaliana U. Malamog, and Dr. Theody B. Saico. So we all know that in irrigation, it is the vital input in every agricultural productivity and agricultural growth. And here in the Philippines, the most common and oldest method of irrigation is the surface irrigation system. And the most common among the surface irrigation system is the furrow irrigation, which requires low capital investment but rather entails high labor requirement and has low application efficiency. So for this study, I'll be using the crop, which is the sweet corn, which is a common crop which uses a furrow irrigation. So I why do I automate this system? So, in rising labor cost, competition for water, and the need to conserve the environment has the, has intensified the move to more advanced system. So, in furrow irrigation system, it has still less or a little mechanization and automatic control than other than the surface irrigation techniques. So in it, automation of the irrigation systems, it enables the farmer to make smart decisions based on accurate and real-time data or the in-field data. A means of ameliorating the problem of high labor requirements and low water use efficiency of surface irrigation systems, which could minimize the water input, human intervention, and improve application efficiency while satisfying the plant's need, is the aim of this automation. So for the objective of the study, it is to develop an automated furrow irrigation system, which I will be calling it an AFIS, to improve irrigation water management in maize. So specifically, it aims to first is to develop both the hardware and software for the automated furrow irrigation system, or which is the AFIS. Next is test and validate the field performance of the AFIS in maize production. And lastly would be to determine the economic viability of the system. So for the materials and methods, so in this picture depicted the design and concept of the whole automated irrigation system. So the AFIS has several components such as the concrete reservoir with motorized offtake and distribution line as a source of irrigation water. The next, another component is the soil moisture sensor, this one, to monitor the real-time soil moisture status of the field, which initiate the opening of the offtake when the reading stretches below 50% moisture allowable deficit. Then another component is the field advanced sensor, or the FAS, which monitors the advancing water from the head furrow until it reaches the sensor located at the end of the furrow and triggers the closing of the offtake, ending the irrigation process. And lastly would be the AFIS microcontroller, which which run the embedded program and control the action and the features of the system. So the field layout of the following sensors are in this picture. So at 2 meters, 30 meters, and 55 meters are my soil sensors. And at 60 meters are my field advanced sensor, because my field is just about 65 meters. So for evaluation of the performance, so it will be looked upon the sensor's ability to transmit the necessary data. And the next would be the agronomic evaluation. So for this one, so an 8 meter by 65 meter, or each block is composed of 10 furrows, which is spaced between 70 centimeter. So I'm using an F1 hybrid sweet corn, which is the Sweet Victory with a 75 days maturity. So for the comparison, I have a block for conventional, meaning the method for irrigation is not automated, and of course the automated system itself. And then for the pest management, weed management, so for the conventional and automated system, so they are all the same, and only the irrigation management differs. So for conventional, so I'm using the farmer's practice, which is 0, 12 days after planting, 30, 45, 60, and 70 days after planting. For automated, so the irrigation management for automated will be based solely on sensor readings. And for system evaluation, so not 30, but rather 90 plants samples per block was obtained to determine the yield and their water use efficiency. So what data collection for other parameters were collected at 20, 27, 34, 41, 48, 55 days after planting. So for the data analysis, I've used the SPSS and the ANOVA and DMRT at 5% level of significance. So for the economic analysis or the viability of the system, so I'll be just using the benefit cost ratio, wherein the present benefit and the present cost will be divided. So as a result, so this is the actual different components of my AFIS or the automated irrigation system. So this is the concrete reservoir with automated offtake. So the installed reservoir was constructed using 324 inches diameter by 39.37 inches long, made of concrete circular culvert. While for the offtake, so it was equipped in the sides of the reservoir. The offtake was made of a 16 inches thick flange steel plate body with 4 holes and a disc valve with a base rubber seal ring, and a 12 volts actuator were connected at the top of the offtake to mechanically operate the device. So the offtake was further connected to the microcontroller, later I will show you, to remotely close and open the offtake during the irrigation process. The next is the actual soil moisture assembly. So for this soil moisture assembly, the general function of this one is it uses a capacitive analog soil moisture sensor, which will measure the soil moisture content by capacitive sensing. So the assembly is composed of the soil panels, and then another feature of this one is using the transceiver, meaning for this sensor, both the soil moisture and the field advanced sensor, I will be installing it wireless, so that farm operation will be not obstructed by using cable wires. So the sensor measured the real-time soil moisture content of the active root zone of the plant, which monitored and scheduled irrigation events when the soil moisture was within the user-defined set point. Then another is the field advanced sensor assembly. So the same almost assembly with my soil moisture sensor. The only difference is that the sensor being used, so I'm using here a water level sensor. So the same it is powered by solar, and then using a wireless transmission. So almost all of the components for FAST resemble that of the soil moisture sensor assembly, except for the sensor used. So the advancing water in the furrow was sensed before it reached the end of the furrow. So this also triggered the termination of irrigation when the water reached the predetermined location of the sensor. Then next is the AFIS microcontroller. So it is composed of an Arduino Mega 2560, which is the brain of the whole system that can sense the environment by receiving input from a variety of sensors, from the soil moisture sensors and from the field advanced sensors, and also from the motors or actuators from my offtake. So for this one, it displays the real-time soil moisture reading of the soil, and a dual motor driver module H bridge at the bottom was also connected to the Arduino Mega to drive the actuator installed in the gate for opening and closing of the gate. So for the whole operation of my system, so please take a look of this video. So that is all for the whole operation of the AFIS. So these are the results. So the system performance of the AFIS. So these are the this dash represents the signals of the sensors which was sent to the microcontroller. So once the signal or once the reading of the soil moisture sensor have reached the MAD at this stage, or the 50% moisture allowable deficit, so it will signal the microcontroller to start the irrigation process. Then for the observed data and data transmission, for the soil moisture sensor, the speed of data transmission was between 100 to 300 milliseconds, which varies depending on the distance of the sensor from the controller. So a total of 2,508 out of 2,880, or 87.08%, were transmitted by the soil moisture sensor to the microcontroller. And then a total of 12.92%, or 372 data points, was failed to be transmitted. So recurrence have been observed, which means that the sensor have signaled to open the gate before its scheduled time of opening. Another is for the field advanced sensors, so the same speed of data transmission from 100 to 300 milliseconds. And for this, FAST successfully transmitted all the signal needed to close the gate. So it took 23 seconds for the gate 1 and 15 seconds for gate 2, the opening and closing, when readings have been sent by the sensors to the AFIS microcontroller. So for the agronomic evaluation of the sweet corn, so I have here all the result from the grain yield and the water use efficiency. For the grain yield, in terms of tons per hectare in conventional, so that is only 9.80 tons per hectare. Well, for automated, so um, it increased in up to 14.10 tons per hectare. So they are statistically different from each other. Then another is the water use efficiency, which is in terms of kilogram per hectare per of water. So for the conventional, that is only 30.06, while for automated, that is 43.25. And same, that is, they are statistically different from each other at 5%. Then for the system viability, so I'm using the benefit cost ratio. So with AFIS, the BCR is 2.37. Without AFIS is 1.45. Although they are all both viable, but a BCR in AFIS was higher compared to the BCR without the AFIS, which indicates that the use of AFIS was feasible with a higher benefit cost ratio than maize production and done without the AFIS. So for another savings is the irrigation labor cost. So 45.76 of the total labor cost in the conventional system was reduced to 21.95% in the automated. So we did not only save labor costs in the irrigation, but also made the process more efficient because we only need less manpower for system maintenance. Then another is reduction in fuel costs, which was also observed in the automated system since the irrigation process but was reduced by the time of operation during irrigation, thus reducing the fuel cost. So to conclude, first is the AFIS was successfully installed, optimizing irrigation process and proved that real-time collection of soil moisture readings and water scheduling and water-efficient technology was potentially a win-win strategy with environmental and social benefits. Another is this study demonstrates that an efficient irrigation management can significantly improve not only grain yield in maize production, but also increase water use efficiency and productivity. So, and lastly, it reduced production costs in the long run, making the maize production industry, or not only maize production, but other crops planted in a furrow irrigation more competitive and sustainable. So, thank you, and that is all for my presentation.
Okay, thank you. So we have a couple of questions. First question is from Ma'am Sheila Ramos. How will an ordinary corn farmer implement the results of your study? Will it be affordable to a small farmer, for example, in the highlands of Bukidnon and Cotabato, who are usually dependent on rain for irrigation?
Yes, sir. So the components was designed that the materials used for those sensors can be sourced out locally available and as simple as we can to program the necessary sensors so that even though farmers can operate them but with themselves, of course, with just a little training.
Okay. So we have a question from the audience for the presentation on automated irrigation system. Uh, sh- um, Diogenes Pasqua is asking, what is the transmission technology that you have used to actually, transmit the data coming from your sensors?
On my sensor, we're using a transceiver. We bought a transceiver which meaning it transmit and then at the same time it receives wirelessly. So within the range of a frequency, so the same frequency, the microcontroller should have the same frequency with the sensor, and using that transceiver so they can communicate with each other. So I'm using a transceiver. Transceiver is to transmit a combination of transmitter and a receiver, sir.
Okay, so a question from Dr. Annalisa Rolon. If a farmer invests on this, in how many years will the investment be recovered, considering increased productivity and increase in water use efficiency?
um, it was not written in my paper or in my presentation, but an ROI of after a year, meaning a year was divided into 4 croppings. So that is meant by a
Okay.
year. So we can recover our cost by more than a year.
Okay. All right. A question from Dr. Tanetan Chuling. How did the yield improve when you introduce automation?
So the yield in automation improve. Again, it's not depicted in my paper, but then aside from the yield, before that I've measured the the size of the cobs, the number of the cobs per plant, and then and after that the number of kernels in the cob. So the automated system has higher um, yield than of the conventional system, since we're not able to validate it, but then maybe the timing of irrigation um, affects the yield of the um, conventional system.
Okay. So, question from Dr. Donabel Balela. Based on previous studies on using automated irrigation system, was your cost-benefit ratio significant, as well as the reduction in the cost of labor?
Yes, sir, because almost a reduction of an almost of 11% in the labor cost. Well, for the BCR ratio, aside from BCR, so we have this new method for determining uh, the introduction of the automated system, wherein you can analyze the scenario of without the AFIS and with AFIS. So by subjecting the test on the with automated system, so there is a significant cost benefit ratio that can be obtained from adding the or a positive outcome from adding the automated system on the usual conventional system of furrow irrigation.
Okay, last question from Dr. Candy Mercado. What are the modifications to the device to be applicable to other types of crops like rice or other or fruit trees? So, yeah.
Maybe for the a little modification like the rice. So I have a colleague which will be studying an automated irrigation, which is a basin for which is for rice. So the difference is that it will not be using the furrow. So maybe the level of water will be just observed in any of the location for rice and or other fruit trees. Well, for other fruit trees, so it can be used since fruit trees can be planted by rows.
Okay. Thank you very much, Sheila,
Thank you, sir.
for your presentation. We will now proceed to, there was a change in the presenters. We will be proceeding directly to Dave Joseph Estrada of Mindanao State University in Iligan Institute of Technology. He'll be presenting his work on silanated coconut oil-based 2K waterborne polyurethane coating for corrosion protection. Dave?
Yes, sir. Let me share my screen. Uh, can you see it now?
Yes, we can see it.
So, good afternoon, everyone. By the way, I'm Dave Joseph Strada, a student from Mindanao State University, and I'll be presenting to you our research entitled Silanated Coconut Oil-Based 2K Waterborne Polyurethane Coating for Corrosion Protection. And this is the flow of this presentation. It starts with an introduction, followed by methodology, results and discussion, and lastly, the summary. To begin with, on the night of December 3, 1984, at least 2,000 people were killed and 600,000 workers were affected in Union Carbide plant in central Indian city of Bhopal. This is due to the emission of at least 30 tons of methyl isocyanate gas. And the main culprit for this most tragic event in the history is due to corrosion. Corrosion can be prevented in so many ways, like the use of metal type, environment measures, sacrificial coating, corrosion inhibitors, and design modifications. However, some of these methods are expensive, limited applicability, and time-consuming to prepare. Thus, the use of protective coating is of great advantage since it is cost-efficient, can be easily prepared, and flexible where we can use it anytime and anywhere. So basically, the coating material will help to inhibit the permeation of corrosive agents to metal underneath. However, this too has harmful effects. Some of the commercial coatings contains chromates and formaldehyde, which are known to be carcinogenic and toxic. Furthermore, presence of volatile organic compounds like toluene, xylene, ethyl acetate, methylene chloride, and glycol will eventually participate in the formation of ozone and will lead to global warming. Thus, looking for an alternative which is both effective and safe for the health and the environment is a must. Polyurethanes are a class of versatile materials with great potentials for use in different applications like insulating material, car manufacturing, and coating. Basically, polyurethane is a product between the reaction of isocyanate and polyol. The major components for the synthesis of PUs or polyurethanes are produced from oil as the feedstock, with the petroleum oil as the feedstock. With the fluctuation of prices of petroleum feedstock, this dangerously affects the price of raw materials for industries. Moreover, the instability regarding the depletion of fossil-based assets and worldwide temperature alteration issues were identified. These problems have led to significant research to replace non-renewable based assets with renewable ones for developing green polymers or bio-based polymers, since it is cost effective and safe for the health and environment. Researchers have gained interest to explore bio-based replacement by introducing vegetable oils. Vegetable oils are non-toxic, non-depletable, domestically abundant, non-volatile, and biodegradable resource. Vegetable oil comprised of triglycerides with glycerol as its backbone and long dangling fatty acids. The reactive and functionality of different vegetable oils depends on the reactive sites, such as double bonds on the fatty acids. This table shows that coconut oil, which is significantly abundant in the Philippines, contains no reactive sites, such as unsaturated bonds. This explains why coconut oil is hardly used in replacement of chemical feedstocks. Fortunately, this problem was already addressed by the Bioproducts Research Lab of MSU-IIT, where they have successfully developed a highly functionalized coconut oil-based polyester polyol. And presented here is in this table are the properties of the synthesized polyol, showing a promising result that is suitable for polyurethane application. However, vegetable oil such as coconut oil contains 80 to 90% long-chain saturated fatty acid, making it intrinsically hydrophobic and reduces its affinity to most metal surfaces, therefore reducing interfacial adhesion with a crucial property for protective coatings. Several researches were conducted to address this concern, and the use of silane is quite conventional. Silane is a silicon-containing compound similar to carbon, silicon that can hold 4 substituents but is more electropositive and has a unique nature. One silicon molecule can have both organic and inorganic reactivity. Thus, silane is widely used as adhesion promoters and coupling agents. Furthermore, the improved corrosion rate could be due to the fact that silane-based coatings are chemically inert and can provide corrosion protection because of their good barrier properties that delay the entry of aggressive species to the metallic surface due to its hydrophobic property as stated by Asadi et al. 2014. So for the novelty of the study, as per the researchers' knowledge, there is no existing research that utilizes coconut oil as the primary source for the making of polyol. Only the work of the Bioproducts Research Lab has successfully developed a highly functionalized coconut oil-based polyester polyol, or CCP, suitable for polyurethane application. And our objectives for this study is to synthesize waterborne polyurethane, or WBPU, coating using coconut oil as partial replacement for petroleum-based polyol. So as a clarification, we are not trying to eliminate fully the use of petroleum-based polyol, but we are trying to minimize the use of it. And we will investigate the effect of tetraethoxysilane, or TEOS, as adhesion promoter in the WBPU matrix in terms of its adhesion strength and corrosion rate. Moving on with the methodology, presented here is the flow of the synthesis part. So first is the synthesis of silanated bio-based WBPU. Second is the application of the synthesized coating of the metal substrate via spin coating. And the testing and characterization, like tape test for the adhesion strength, potential dipolarization to determine the corrosion rate, and FTIR. And the limitation in these experiments are the NCOOH ratio was kept constant at 1.2:1. The ionized water will be used as dissolvent, and all experiments were conducted in an ambient condition. Results and discussion part. So the FTIR was utilized to determine the presence of chemical composition present in the samples, and it can be seen that molecular vibrations of NH stretch, the OH stretch, the CO double bond stretch, the OH stretch are the fingerprint absorption bands for polyurethane. Suffice it to say that we have synthesized a polyurethane material made from coconut oil. Furthermore, molecular vibrations intended for SIOSI observed at wave number 966. So let us take a zoom of it somewhere here. It can be observed at 1% silane loading. And according to Asadi et al. 2014, the functionality of SIOSI provides good adhesion and lower corrosion rate of protective coating, thus could be a good candidate as adhesion promoter. So for the evaluation of adhesion strength, the tape test method was utilized using an ESTM D3359-17. You can observe from these figures, the average remained area tends to increase as the silane loading increases. To determine whether or not the addition of silane greatly affects the adhesion strength of the coating, the one-way ANOVA was calculated. The p-value is equal to 0.047, which is a bit lower from the threshold value of 0.05. Therefore, there is a significant difference on its adhesion strength. This could be due to the SIOSI formed at the surface of the metal coating, which improves the compatibility of WPU with metal surface, according to the work of Dodange et al. 2020. So presented here is the graph known as Tafel plot. So this plot is representing the relationship between the applied potential, which is the x-axis, and the logarithmic of current density, or the y-axis. It can then be utilized to find the values of the Tafel slope, corrosion current density, and corrosion potential utilizing the extrapolation approach. So in this figure, a shift to lower current density is observed as the saline loading increases. So to further support this result, the corrosion rate was also calculated. Using the informations coming from the Tafel plot, the corrosion rate can now be calculated using this formula. And based from this table, the corrosion rate significantly decreases as the silane loading increases. It indicates that the incorporation of silane on the improvement of corrosion resistance with SiO(Si) acts as an inhibitory effect additive with WBPU, and this result is in good agreement with the work of Asadi et al. 2014. So in summary, we have successfully synthesized silinated WBPU from coconut oil-based polyol. FDIR spectra reveals the presence of SiO(Si), which enhances the material property. Adhesion strength shows a significant increase as TEOS loading increases up to 1 weight%, and addition of TEOS leads to lower concentration. And that's all. Thank you and God bless.
Okay, thank you, Dave. The floor is now open for questions. From Mom Sheila Ramos, how is your coating comparable in terms of effectivity and cost to commercially available corrosion protection products?
Well, thank you for that, ma'am. In terms of corrosion rate, it is comparable, especially with the 1 weight%. Especially with the 1 weight%, since the remained area is equal to 98.33%. However, we did not test the corrosion rate comparing it to the commercial one.
Okay, another question from Ma'am Candy Mercado. Is the coating abrasion resistant? And then a follow-up to that, can you describe the mechanical properties of the coating?
Thank you for that. We haven't yet tested using a UTM, sir.
Okay, so you have another question here from the audience from Diogenes Pascua. Can the coating be applied readily now? For example, as coating for boats, marine applications specifically.
We are still on the process of the feasibility of the study, sir. We don't know yet if it is possible for that certain application.
Okay. Last question from Ma'am Donabel. Can you provide insights on the mechanical properties of the coating? Did you try to perform scratch tests, for example?
We haven't yet, sir.
Okay. All right. Thank you, Dave, for that interesting take on designing polyurethane for corrosion resistant, designing corrosive resistant coatings. And then thank you very much. We'll now proceed to our last but not the least, certainly not the least speaker, Cielo Frianeza from the De La Salle University. Cielo will present qualitative risk assessment of tailings dam. Cielo?
Is my screen visible?
Yeah, your screen is already visible.
Okay, thank you. Good afternoon. I'm Shella Frianesa, and I am here to discuss The Qualitative Risk Assessment of Tailings Dam, co-written with Dr. Andres Oreta. Tailings in the form of slurry is composed of the uneconomical ore, excess water from the mining process, and hazardous substances which are stored in facilities like tailings dams. There is no publicly accessible inventory of tailings dam in the Philippines. Hence, most data from recorded tailings dam failure, which often occurs. Moreover, there is a lack of publicly accessible qualitative or quantitative risk assessments for active and inactive tailings dam in the Philippines. Tailings dam failure impacts the environment severely due to the discharged toxic waste. Thus, the study aims to assess the risk of tailings dam failure to avoid such disasters by applying preliminary qualitative checklist rating and failure modes and effects analysis, or FMEA, on an active tailings dam. The study will focus on risk assessment, wherein the element at risk, which are tailings dam, vulnerability of the element at risk, and hazard occurrence will be identified. The qualitative risk assessment will be conducted by using FMEA. FMEA is useful in identifying and prioritizing necessary detection and mitigation actions. The first step of FMEA is to establish the levels, from system, subsystems, down to the basic components and its functions. After identifying the root causes of the failure modes of each component, the effects will be identified in accordance to each level, so that detection, control, and mitigation measures can be formulated to prevent disasters or lessen the losses. The following are the most common factors that contribute to the vulnerability of the element at risk. Dams constructed using upstream method depend on the tailings for support. It is not for areas with high seismic activity, and it also has a high phreatic line. Thus, it is more prone to piping. The height of the dam also affects the vulnerability since higher tailings dams are less stable. The systems of tailings dams are very important because inadequate systems often result in a higher phreatic line. While the date of construction of a tailings dam is also an important factor to determine whether the design is sufficient or should be improved, since it is most likely based on the best information at the time. Furthermore, active tailings dams are more likely to fail than inactive tailings dams. These vulnerabilities, when triggered by a natural hazard, will result in tailings spill. Overtopping is the overflow of tailings from the tailings dam with a high energy that will destabilize a large portion of the wall, while external erosion is the removal of material from tailings dam wall that will decrease the capability of the wall to retain tailings. Internal erosion or piping due to seepage forms seepage channels or voids in the tailings dam wall, which will weaken the structure. Slope instability, wherein the material will slide along the embankment, will weaken the structure due to the removal of a portion of the wall that holds the tailings. Seismic vulnerabilities, such as uncompacted materials and saturated tailings, will likely cause destabilization once triggered by an earthquake. Thus, proper foundation design should be applied by ensuring that the material beneath the slope of the embankment is sufficient to support the load to avoid failure when dynamic or static forces are applied. Inadequate structural design pertaining to the drainage system should be avoided to prevent tailings spill, since most components of the drainage system, such as pipes, are prone to breakage that would leak tailings. For tailings dam located near an underground mine, settlement of foundation is more likely to happen when triggered by natural hazards. Since there is no directory of active and inactive tailings dam in the Philippines, the directory of the operational mines in the Philippines was used to identify locations that are prone to heavy rainfall and earthquake, assuming that the tailings dam of the corresponding operational mine is in proximity. The mines located in Zambales, Leyte, Rizal, Albay, Camarines Sur, Bulacan, Batangas, and Dinagat Island have a high typhoon incidence, while mines in Abra and Isabela have a very high typhoon incidence. Thus, the tailings dam located near the corresponding mines are susceptible to failure triggered by heavy rainfall. On the other hand, mines located in South Cotabato, Surigao del Norte, Agusan del Norte, Dinagat Island, and Sarangani experience approximately 48 to 75 earthquake hits per year, while some mines in Agusan del Sur, Surigao del Norte, and Surigao del Sur experience 76 to 100 earthquake hits per year. Thus, tailings dams located near the corresponding mines are susceptible to earthquake-induced failure. Mines that experience high to very high typhoon incidence and 48 to 100 earthquake hits per year are located in Benguet, Nueva Vizcaya, Pangasinan, La Union, and Bataan. There are 18 tailings dam disaster events and 16 failed tailings dam in the Philippines. It was inferred that the upstream method was used in areas that experience high seismic activity. Since the Philippines experienced several typhoons, heavy rain triggered majority of the recorded tailings dam failure. In addition, the majority of tailings dam failures were caused by overtopping, since the drainage system could not accommodate the excessive volume of water brought by heavy rain. On the other hand, 33% of tailings dam failure are caused by structural failure, which include breach in pipes due to the additional external forces from extreme conditions. Failure of the foundation to support the load of the tailings dam is also 17% of the cause of tailings dam failure. From the reports, the tailings spill is composed of acidic mine water and sediments that contain hazardous substances. Thus, some bodies of water such as Boak River and Mogpog River were declared biologically dead after the tailings spill. In the study, prior to the qualitative risk assessment using FMEA, preliminary qualitative checklist rating is conducted to determine the risk class of the whole system or the tailings dam, since FMEA is an intensive assessment. The vulnerabilities, hazard, and occurrence of the hazards are given ratings, in which the product of the three is the risk number. Risk number determines whether the tailings dam has a high, medium, or low risk of breach, which can be used to prioritize which dam requires a more extensive risk assessment. The qualitative risk assessment of an active tailings dam, Padcal Mine Site Tailings Pond 3, was conducted by using the Preliminary Qualitative Checklist Rating and FMEA. Last 2012, the penstock A of Tailings Pond 3 in Padcal to Benguet was breached, releasing contaminants onto Balog River, Agno River, and San Roque Dam. During the rehabilitation after the incident in 2012, sinkholes due to the underground block cave were also found underneath the tailings pond, which was plugged using concrete spheres, and the tunnels were completely sealed by concrete to prevent leakage. Thus, spillways were built to drain water from the tailings dam. The Padcal Mine Site Tailings Pond 3 was classified as a risk class 3, hence FMEA was applied to determine which components are susceptible to breach that would lead to the failure of the whole system. It was inferred that the failure modes that will lead to the tailings dam breach are overtopping, inadequate structural design, inadequate foundation design, mine subsidence, and seismic vulnerability as summarized in the table. The study recommends the incorporation of weights on factors that affect the risk of tailings dam to fail. Since the data used in FMEA of tailings pond 3 is not sufficient to have an accurate analysis of the effect that can be used as a basis to formulate preventive measures, it is recommended that FMEA for tailings dam should be conducted based on actual design and condition of the chosen dam, aside from reports and news articles. The following are the references used for the study. Thank you for listening.
Thank you, Shelo. We have a question now from Ma'am Sheila Ramos. Her question is, were you able to connect with any of the mining companies in the Philippines? The follow-up is, will our mining companies be willing to adopt the technology you are proposing as to risk assessment of their tailing dams? Or how is your technology compared to the current technologies that the mining companies could probably be using?
I didn't had the chance to connect with other mining companies, but based on the literature, FMEA is used on tailings dam. But based on the reports available for the Philippines, there are no publicly accessible qualitative or even quantitative risk assessment. So I believe applying a qualitative risk assessment on existing and inactive tailings dam should be a priority since tailings dam really do often fail. Thank you.
Okay. Thank you. Do you have other questions from the audience or from our panel? I think that's it. Yeah. Thank you very much, Shello, for the interesting talk of having, giving us an insight on what's happening on a certain aspect of environmental systems that are not really tapped into, not really looked into in the Philippines. So thank you. So again, we're just confirming with our secretariat. We have already had all of our presenters deliver their talk, and the panel will be deliberating on who will be our best presenters for this afternoon. Please, may I request our attendees to please stay while we wait for the results of the deliberation. And so also for the benefit of everyone in the audience, tomorrow will be the ICT session, Information and Communications Technology session for the ERDT National Conference, Virtual Conference 2020. Our guest speaker for tomorrow's session is Dr. John Kabibihan. He is based currently in Qatar University in Qatar. So for those who would like to attend, the information I think is made available by by ERDT as well as the Secretariat. So please do find, if you are free tomorrow, please do find time to join tomorrow's ICT session. So while we are waiting for the deliberations, they are discussing it as of the moment. I do hope that all of you in the audience were able to pick up a lot of things from starting this morning all the way up to this afternoon. It tells us that encompassing fields, or the particular work that we do as engineers, and often we utilize various tools way beyond our comfort zone, way beyond our expertise. And I think that is the most important aspect. One of the most important aspects, as as engineers who tend to work in highly multidisciplinary environment. So you see a lot of people working on utilizing information systems, databases, chemical systems, material syntheses, designing of equipment, automating it with sensors, so on and so forth. And all of those are working on under the realm of environment and infrastructure. So something that's very important. And as one of as I believe our keynote speaker mentioned earlier, environment and infrastructure actually go hand in hand, specifically as we try to face the impacts of climate change. So I do hope our students, our researchers got more idea and got more opportunities. Okay, and also I'm going to plug this one as well. We have for the manufacturing materials and manufacturing session um, on December 10th, the fourth session on Thursday, Mr. Rafael Nestor Mantaring. He is a very known, well experienced expert on the industry, and he is also part of the academe before. So I hope you do find time as well to see how manufacturing, the manufacturing and machinery sectors are actually trying to evolve, especially in the idea of in the realm of Industry 4.0. So as we try to catch up with I 4.0, and as we try to improve the efficiency of processes, making sure that they are smart, they are efficient, and they're actually sustainable as well. So we're almost there. I mean, our panels are really having a good time, a hard time, I would say, in trying to have the results of our best presenters for this session. And on Friday, we have a special session as well under the SME, Semiconductor Materials and Electronics. We will have our keynote speaker is Dr. Jocelyn Villaverde, who is she is a professor at the School of Electrical and Electronics and Computers Engineering at Mapua University. So she will be the keynote speaker for Friday. And I believe all attendees in this conference have a copy of the ERDT conference proceeding. Am I correct to the Secretariat? May copy po ang ating mga attendees, no? Ng Okay, so I think sometimes you get their information on, let's say, the email address of a certain researcher you wanted to ask, you wanted to connect to. I do encourage all our students, all our researchers to actually, if you see an abstract, if you see a presentation and there is the corresponding author in there with the contact information, please do find the time to send them an email or communicate with them, especially if you wanted to inquire on something or you wanted to start a collaborative work or engagement with them. So this is also an opportunity. So the whole ERDT National Conference is also an opportunity to network, to partner with researchers across, from other partner universities or someone outside your field. So please do find the time to make this one whole week from Monday to Friday or kahapon ata nagsimula Monday up to Friday to actually tap onto those possible networks for your own, research and for your own career as well. Okay, I would like to call on Dr. Sheila Ramos, our session chair, to announce the best paper, the winner for the best paper. You may yes, ma'am. Thank you, ma'am.
Okay, good afternoon, everyone. So we're almost done. First of all, I would like to acknowledge the efforts of our panelists who really made this looking into, judging, and listening to, and commenting on our various presentations. These are our mentors, and they have been very helpful even on a holiday. Thank you, Mom Donabel Balala, Dr. Candy Mercado, of course, Ma'am Annalie, my mentor, and of course, Ma'am Ma'am Tonet Tanchaling, thank you very much for your time and for your efforts in doing all of this. We have learned a lot, starting from Dr. Eric Paringet's lecture this morning. So everybody who are with us in this activity for the almost whole day, we are learning much, especially in terms of directions of our different research endeavors, both in environmental and civil engineering work. And we learned that we really have to be transdisciplinary this time in terms of all our efforts in this. We are very happy to announce the winner for, I think this is the best paper, sir, not the best presenter, right? The best paper for Envi and Infratrack.
Yes, ma'am. It's a best
Do
paper.
we
Yes,
have,
ma'am.
yes, do we have a monetary prize for this, sir?
Maybe the secretariat can.
Because I remembered in 2011, I was privileged to have this. I won in that time. I was given 5,000 pesos, and I think this time, how much do we give to our to our winners if we do have prizes
Oh, there's
for that matter?
there's I think there's no
What
monetary
year because of maybe because of the pandemic. Anyway,
probably.
we are congratulations to everyone. Every presenter really made their best efforts to explain to us that we may be able to understand how they are doing with the different researches. But we have to choose, and in for number one, and we already identified one, but there are many of you. There are three, I think, for number two, and for that, can we have a drum roll, a virtual drum roll for us to announce the winner? Okay, so the winner for this Enfra and Invite Truck, okay, is no other than presenter from UPD. Uh, his work is into calorimetric detection of copper ions in water using polymer decorated silver nanoparticles. So we have Edgar Clyde R. Lopez. Congratulations, Mr. Lopez, of your excellent work. Thank you for being with us for this day.
Congrats, Edgar. Yeah, he is in the attendees already. Congratulations, Edgar.
Congrats, Edgar. Congratulations. And for everybody, congratulations. You did
Yes, yeah.
excellent for this event.
Congratulations to all. Thank you very much, Ma'am Sheila. Thank you very much po. Also to our panelists. And to close this session, maybe call on our project leader for ERDT from UP Diliman, Dr. Gerald Joe C. Denoga. Sir, happy?
Hello, good afternoon, everybody. And first of all, congratulations to Edgar and to, of course, his mentor for his paper. Job well done. While I can't say that our judges had an easy time looking through all of the presentations today. So once again, congratulations, Edgar. And is he still in the lineup po natin?
He is in the attendee, sir.
Okay.
Yeah.
Okay. So as we close this particular session, I would like to thank everybody for attending. I know it's been a big deal, especially the fact that it is a holiday, but the ERDT National Conference spans 5 days, and this is one of our sessions. And I thank the different panels. I believe that there are actually other panels from the different sessions in our audience. For example, from the energy panel, we have Dr. Lucidis Linda Belotindos, Dr. Rodel Guerrero, Dr. Marvin Sinense, and Engineer Isabelo Rabuya. Thank you for being part of our energy panel yesterday. And For today, of course, we have our esteemed panelists. We have Dr. Mary Donabel Balela, Dr. Candy Mercado, Dr. Annalisa Rollion, and Dr. Maria Antonia Tanchuling. Thank you very much for really helping us out with this. You have been very, very patient, looking through all of the 13 presenters, and we really appreciate the efforts and your presence here. I would also like to acknowledge the presence of our ERDT project leaders, my fellow project leaders, including Dr. Evelyn Tabuada from the University of San Carlos. We have Dr. Noel Esteperes from MSU, IIT. We have Dr. Jonathan Dunca from DLSU. And of course, we have Professor Ferdinand G. Managdeg from UP Diliman, our program leader for the ERDT. And last but not least, I would like to thank our moderator, Dr. Brian Alamani. Brian, thank you very much. And of course, our session chair, Dr. Sheila Ramos. And our staff, led by Ms. Mayvi Alas, and everybody who has helped out in making this ERDT National Conference a success. Now, as we close, I would like to invite you guys to witness and preferably participate in the other sessions that we have. So we have the semicon, we have the manufacturing session, and we also have the ICT sessions for the next 3 days. So I think those links were flashed below before, and those links are still available on our website. And we have a lot of great speakers in store for us for the next few days. And I hope that you will be enlightened by the other presentations that we have in store for you. And at the very least, today we have had a lot of presentations that were very diverse and were very insightful. I was actually glued to a lot of them, and it was just amusing that we had already closed into the lunch break, but we still kept on going simply because there was a lot of knowledge that was shared. So once again, thank you everybody, and have a good day.
Thank you very much, Sir Happy. Again, good afternoon to everyone, and see you tomorrow and in the coming days. Enjoy the rest of the conference.
Thank you.
Thank you. Sheila, where are you?
Hello. Let